Physics Part 52. Graphs of the kinematic equations. It is often useful to represent the motion of a particle graphically instead by means of a series of equations. In this section, we bring together the graphs which correspond to the equations we have already derived. We shall see that there are some important links between the graphs. First, think about a particle moving in a straight line with constant velocity. Constant velocity means that the particle covers equal distance in equal intervals of time. A graph of displacement x against time is t is thus a straight line as provided in the figure. Here the particle has started at x, which is equal to 0, at time, which is again equal to 0. The slope of the graph is equal to the magnitude of the velocity, since from the definition of average velocity, v, is equal to x2 minus x1 divided by t2 minus t1 is equal to delta x divided by delta t. Because this graph is a straight line, the average velocity and the instantaneous velocity are the same. The equation describing the graph is x is equal to vt. Now think about a particle moving in a straight line with constant acceleration. The particle's velocity will change by equal amounts in equal intervals of time. A graph of the magnitude v of the velocity against time t will be a straight line. Here the particle has started with velocity u at a time t which is equal to 0. The slope of the graph is equal to the magnitude of the acceleration. The graph is a straight line showing that the acceleration is constant. The equation describing the graph is v is equal to u plus at. An important feature of the velocity minus time graph is that we can deduce the displacement of the particle by calculating the area between the graph and the t-axis between appropriate limits of time. Suppose we want to obtain the displacement of the particle between times t1 and t2. Between these times, average velocity v is represented by the horizontal line AB. The area between the graph and the t-axis is equal to the area of the rectangle whose top edge is AB, or average velocity. This area is average velocity delta t, but by the definition of average velocity is equal to delta x divided by delta t. Average velocity delta t is equal to the displacement of delta x during the time interval delta t. We can deduce the graph of displacement s against time t from the velocity time graph by calculating the area between the graph and the t-axis for a succession of values of t. As shown in the figure, we can split the area up into a number of rectangles. The displacement at a certain time is then just the sum of the areas of the rectangles up to that time. Well, the results of plotting the displacement s determined in this way against time t, it is a curve.